Okay, so I guess when the COVID-19 pandemic started, firstly, one of the most effective way for preventing the disease spread is something called social distancing. But then you come up, how do we assess the social distance? And then both Apple and Google come up with this mobility report. Apparently, this is all based on cell phone movement in different areas. So but I don't know exactly how they did this, but Apple and Google both had different ways of mobility reporting to approximate the social distance practicing at the different regions. And there are subtle difference between Google mobility and Apple mobility. But they are also very similar in a way. So the Google actually also provide, wow, it's global mobility, including different countries. So what we are going to analyze is actually the regional mobility result. Uh, we are actually just look at the USA. Yeah, oops, US. Yeah. So officially, if you go to the Google downloaded regional mobility report, you actually see a lot of countries, and the US is just one of them. Let's see. US. U. Huh. It's not alphabetic order apparently. Sorry, but it's actually much easier if you use the code to list for it. So in this case, if we go back to the R Markdown file, that would be around line 244. We start with chapter uh, uh, but chapter 3, Google mobility analysis. So and in previous year, well, actually, in my previous workshop, we have to download the mobility data and zip file, unzip it, and then load it. Apparently, recently, GitHub now allow me to upload the mobility report CSV file directly to GitHub. So you can actually skip this part, downloading part, and just read it directly from the reports from your downloading directory. So that's actually should be if you open your file, you should see a download folder. And inside the download folder is another folder called Google. And inside of that Google, there should be two reporting files. Apparently, Google actually separated the mobility report by year. So there's a 2020 report. There's also a 2021 report. And so we actually have to read 2020 and 2021 as the two separate data frame and then merge them into one data frame. So it's a good exercise. So this is basically what the Google mobility report is. But since we have to analyze them as a one, if we analyze one county, we want to analyze continuously. So we get these two reports, merge them, and then do the analysis. So it's a good exercise. So here, I first read the 2020 US Regional Mobility Report. TB Google Mobility GM US 2020. So My apology. Oh, sorry, my kids just run over here. This is 2020. The next one will be 2021. Table for GM, Google Mobility, US 2021. 2021 US Regional Mobility Report. Okay. So okay, so you can actually see country regional code US, country regional United States, subregion Wyoming, subregion 2 Western country. So apparently, well, now what you see is the Google mobility data are in different format with the COVID-19 cases data from the Johns Hopkins. So this one apparently the dates is every day is by rows, but the county name is different. The county name actually, if you recall in the Johns Hopkins data is at say Macon, Alabama, US. But apparently in Google Mobility, that will be a Macon County, Alabama, United States. And this, obviously Google and Johns Hopkins, they don't really work together. So they just use different name as they like. So, but this is also a very common issue when we do data analysis. When we pull the data set from different resources, from different sources, they may or may not in a different format. And in fact, very commonly they are not in the same format. And we have to somehow merge the data set into the same format. So well, the good thing is for Google itself, it's quite consistent. So this is 2020 data, but the 2021 data, they follow exactly the same format. It's just the dates are different. I'm not sure why they put this into two different files, but well, it's a good exercise for us. So and because the Google 2020 or 2021, they have exactly the same format, it's actually quite easy to merge them. All we have to do is just so-called stacking them. Stacking can be done something called R-bind. So if we type the question mark R-bind, what this R-bind, this is actually a very basic function. It's something called a base package, I-bind. And well, there's also another command called C-bind, which is column bind. This is I-bind means a row bind. Basically, a combined object by rows, in this case, data frame. So because Google 2020 or 2021 have exactly the same column format, so we just combine them by rows, and we call that GMUS, Google Mobility for the US. So if we do that, oh, I haven't run the 2021. Okay, in this case, what I go back and just rerun this tab. Okay, now I should have it. Okay, so now if I go back to my environment table, environment window, see TBGMUS. So you can actually see, so TBGMUS 20 has about what? 812,000 observation, 812,000 rows. TBGMUS 21 has about 344,000 rows. All combined together, I have 1,000,000. That seems correct, is it? Sorry, 5 plus 4, 9. Yes, actually, if you add these two tables, it looks like that's exactly the number of rows I will get, and they all have 15 columns. So this is actually correct. Seem to be at least on the dimension. But then you can also see Well, there's a lot of NA. NA actually basically means not available missing value. So there's a lot of a missing value here. So I think minus 24 means below the baseline. 1 means above the baseline. So minus 18 will be 18% below baseline. In any case, it's all relative. So there's a baseline, minus means it's below baseline, plus means it's above baseline. So you can actually see, whoops, when the workplace is below baseline, and then you see the park and the recreational area are above baseline. So it's actually seems to make sense. When people don't work, they go to park. So now in this case, the county name in the Google Mobility is going to be called Macon County. And the state is still Alabama. So we are going to pick the Macon County and Alabama from this report. So we are going to use a filter. So the state is the subregional 1 in the Google format. The county is a subregional 2 in the Google format. Let's double check. Yeah, state. Yes, subregional 1 is Alabama, subregional 2. Apparently, there's also a lot of NA. That's probably the state average, actually. But this is now the county name now. So, okay. And so this, obviously, the column name are also quite different between the Google Mobility and the Johns Hopkins. And there's no other way except just read the data and read the instruction and then figure out what is what. So, okay. So now we just pick the Macon County from Alabama from Google Mobility. So there. So, and well, you also see, let's see, the date, yes, from February. Yeah, you see a lot of NA as well. So this park percentage change from baseline, there's a lot of NAL. And that's because apparently Google Mobility Report in some cases, because there are privacy issues, so they have to filter out some, I don't know how they do this, but apparently when they do not have enough data, either because of no reporting or because of privacy issues, they will put missing data there. So, or when the quality, or so-called the data has low quality, they will also put missing data there. So in a case, this will be a very messy data. So, and we can actually look at the most recent data. Also, the Google Mobility is not a real-time data case. Apparently, this most recently updated in May 12th. Oh, that's it because also I didn't do the most recent check. We are only reading this from my GitHub repository. So the most recent date in the file I put it is May 12th, which is 5 days ago. Yeah. So, but the Johns Hopkins data, because we are reading it directly from the Johns Hopkins reporting site, that actually is yesterday, the most recent reporting date. So, well, obviously, Google Mobility and Johns Hopkins, they do not exactly match. So, and so the good things about RStudio to merge the R to merge the data set as a data frame is actually quite straightforward. But what we need to make sure those keywords are going to match. Let's first look at the, I guess this is first look at the daily cases for the Macon County. And this is Macon County, we have the date, we call it the YMD, year, month, and the date. And then that's just Macon, Alabama, the name of the county. So what we are going to do, because we are going to merge by the dates, so I'm going to rename the YMD. Also because once we merge everything for Macon County, and then this is not informative anymore. So I'm going to call this daily cases. So I'm going to rename my data, this TB daily sub as something else as daily cases and the date. That way, when I merge the COVID-19 case data with mobility, and then I have more informative column names. Okay. So this is after I rename the column name. So this is now called daily cases, and the other one just called date. In fact, you can actually see also the type of data. So the date is actually a data type. And the daily cases actually seem to be a floating number, double decision. Okay, that's actually seem to be default presented by the R, so our tidyverse. So okay, so then, well, actually, I'm going to merge the TB my county data. Let's. I'm going to. Okay, this is. Oh no, that's the daily cases. TB mobility. Is this okay? The mobility for the Alabama Macon is like this. It has the date. It has something called retail recreation percentage change from baseline, grocery, park, transit, but then the date. What I want to use a date as a basically every day I'm going to match the mobility with the COVID-19 cases. So the date will be the keyword I'm going to be the variable I'm going to merge these two data frames. Okay, so the key function is here, merge. And if you look at the help information on merge, the merge is actually a base package. It's actually not part of the tidyverse. Merge is basically taking two data frames X and Y and merge by intersecting the names. But in this case, I actually specifically say look for date based on the date. And we're not going to pick anything in Y. Basically, if there's a missing value there, I think it will be put as going to be removed. That's my recollection. So after we merge that, I actually rename the row name also as a date, and then visually check the merging result. So yeah. So basically, that's what the keyword is. So merge. In this case, X is the daily cases, Y is the Google mobility, and merge everything by date. Okay, if I run this, TBGM COVID my county. So that's the new name for this TBGM COVID my county. So this is the table contain both Google Mobility and COVID for just this county. In this case, it's Macon, Alabama. So, okay, so we have a date at the first column, daily cases. And then this is basically COVID-19 data. And then that's basically Google Mobility data. So US, yeah. So there's a lot of redundant information here. So I'm missing value. Yeah, there's a lot of here. And now you see some transit data, workplace, residential. Apparently residential is NA. Apparently in Macon County, Google does not have a reasonable mobility report. So the residential mobility score here is missing. That's actually from June 11 last year to May 12 this year. So that's from Macon County, Alabama. Well, you can also see the error here. So apparently, when the COVID-19 cases are reported, sometimes they actually retract it. So even though sometimes they report a case and then they say this is not, or maybe this person doesn't belong to our county. He's visiting, I guess this is he should be counted at other places. Yeah. So you can even see -1 case report. So it actually happened quite often if it goes back. So I guess if this is the election result, someone must cry conspiracy right now. So anyhow, but this is what the case COVID-19 case reporting right now. So there are actually minus cases in the reporting. So okay. We can also look at the names using R specifically. So in this case, there are 16 columns there after merge. Daily cases, and those are all ported from the Google Mobility report. Once we have this, this is just printed how many columns. Basically, in the first row, how many elements are there? There are 16 of them. So if we want to overlay them, in many cases, you want to check different data set. In this year, we want to look at the COVID-19 cases. And then mobility. The very intuitive way is just to overlay the two data. Now, if we do that, you will see, well, this is integer level, 1, 2, something. But the mobility score is actually much larger. And well, negatively at -20, they are not at the same scale. So if we overlay them, then on the same axis, the small number will look very small, but the larger number will dominate the small number. So when we overlay two different scale of data, very often we want to normalize them to the same scale. And then when we visualize these two different time series, the trend will become more obvious. So, in this case, I'm also selecting different columns. I basically remove some unnecessary columns. So here, I'm going to just remove all those code, subregion, apparently FIPS is the census code. Remove all those. Those are basically the same thing repeated again and again. So, okay, so I pick only the values I can just say run selected lines there. So in this case, there. Basically, I'm picking only the values. I didn't filter out the missing value, but just picking the values. So. And then I use the function called scale. Scale is also a base function. Basically, scale and center the object. The center by default is a 0. Scale is put everything between 0 and 1. So in this case, I'm going to scale everything in this new data frame, TB, GM, COVID, my content number 2, centered around 0 and scale it between 0 and 1. So I run selected lines there. So you can see now, actually, it's actually not between 0 and it's just normalized. So that seems to be a normal distribution divided by standard deviation, I guess. Yeah. So 1.1. It can be bigger than 1 when the value is outside of that standard deviation. So, and then this basically put the dates also back. So, okay, so let's see. Okay, it looks like the data is scaled. And the way to check the data is scaled is also do a summary to see how this look like. So, the mean value is 0. Okay, very good. Mean value is 0, 0. Well, there's also not available, but there's no data there. So 0. So the mean is all 0. And the median 0.3, median 0.05. That's actually interesting. The median is, how about the first quantile, 0.67, minus 0.2. It doesn't look like it's normalized distribution. It's just the normalized scales. So even though the data are in different distributions, the quantile are not the same. So it's just the mean value are there. The first quantile are not the same. So it's actually, my understanding is just the least score calculation. So once we have everything on the similar scale, now we can actually put them in the same overlay plot. So this is what the overlay does. Now, the way for ggplot to plot everything is still, ggplot seems to only handle the two value, x and y. But how do we generate a multiple plot? Apparently that is controlled by color. And so the way for ggplot to plot multiple variable is actually first call it melt. Melt those multiple columns into the same, into a pairwise column, but coded in a different ways. Personally, I think this is because ggplot is still a new package. I hadn't been able to deal with multiple plot in a more intuitive ways. So this is my current understanding. This is because ggplot doesn't know how to handle multiple variable plot. I think later on you'll have a better way to do it, but this is currently that's how ggplot handles it. So I'm going to plot what daily cases was transit and workplace and residential. This may not, and then by date. So I'm going to overlay those daily COVID-19 cases with the mobility. Google Mobility has something called transit, workplace, and residential. The residential may not work because there are so many not available. So I'm going to remove the residential because residential has so many not available. So for Macon County, it's not working. So I'm going to only pick daily cases, transit, and workplace. And then we have to so-called melt them into the pairwise column. This is actually also looks not very intuitive. What this melt trying to do is, I'm going to melt the data frame, which is this scaled data frame. And then the variable are those selected columns. The selected columns are here. And 3 columns, daily cases, transit, and workplace mobility. After I melt them, I'm going to call those melted values, and the names are basically coded as a variables. And this looks not very intuitive, but if I run this code and look at the result, maybe it's a little helpful. So this is melt function after I operate it. So there. So now I have the values and the variable are here. So the variable, so the values are there. The variable, this is the workplace, transit. So what this means is basically put everything into 2 columns, and then ggplot can handle this. So this is really a bit awkward, right? So, but that's what the ggplot deal with this. I hope in future release, ggplot can remove this kind of awkward handling of this. But at the moment, this is how it does this. And then we follow with ggplot. And so instead of operating on the original data frame, we have to operating on this melted data frame, df_melt. And in this case, we are going to plot with a date and a value. Why is called value? Because I called there. That seems to be is called value, is it? I didn't call it. It looks like it's not even case sensitive. Oh, it actually is a lower value and variable. So it looks like this 2 line is not even working. Hold on. That's still lower cases. Value and variable. It looks like data is still there. So. Oh, it is there because it's actually converted into a different line. Sorry, my mistake. So it is working. Sorry, my apology. And then we added a smoothing function there, smoothing trend line. So, and for this one, I also put the title there and just make sure we know which places we are looking at. So, okay. So after these 4 lines, this is the plot we have. So the variable, that's the after melting. This is what the after melting the variable is. So the variable there, daily cases. and then transit, right? So, and then the value. So basically, it has to treat this variable in two different columns. This is what the ggplot does. But it actually gives a color according to that variable. So daily cases is red. So it seems to make sense and peak around January. This October, January, that's probably November, December. So, and the green is a transit. I'm not sure exactly what transit definition is. My understanding, people traveling to, I don't know, the airport to people driving on the highway, that's probably count as a transit. And workplace, this is actually quite intuitive. Basically, on the Google map, Google thinks some place are workplace, and then the cell phone signal there goes down. It seemed to be quite reasonable. During the Christmas break, the workplace goes down dramatically. So, but transit, transit also goes down, not very high, but we are missing the residential. Apparently, for the Macon County, the residential mobility is missing. So, my guess is, because the cases indeed pick up, the residential mobility probably is increasing, but apparently Google Mobility does not have a report from Macon County. So, but this is what the data is. Now Google just do not have a quality report for the Macon County. So yeah, it's basically NA. Residential is basically a lot of NA. So it does not have a good quality report. So there, that's we still have we are actually roughly on time. So we can actually change data to a different place. See whether, so for the remaining time, you can actually try to change the county into a different place. So I guess if we, what is Montgomery? Montgomery, Alabama, which county is that? Montgomery, Alabama. Which county is that? We can check that into a different county, see how it looks like. I guess it's called Montgomery County. Okay, that's easier. So let's just change that to Montgomery, see how it looks like.
If you just hit the all button, it will replace all of them.
Oh, okay. Let me see. Montgomery. How do I spell Montgomery? Okay, good. That's one of current. Okay, let's see whether that it works or not. Let's run all. Actually, I'm going to just generate a net report. Oh, it'll be very interesting if this just worked. Just replace Macon with all Montgomery, it worked. It doesn't look like it is working. It's actually generating report. At least there's no bug. At least hadn't stopped. So okay, let's see whether it's okay. COVID-19 transmission. Examine the daily cases. Okay, it checked that into Montgomery. Okay, so plot the daily cases. Oh, it does look like this is much higher. And for the Macon, the highest is only 5. For the Montgomery, the highest cases look like 450 something. Okay, so this is much higher now, but actually similar trend. It still peak around January. So it also does look like goes up a little bit recently. So that's actually seems to be consistent with the Macon County as well. So, and it would be interesting actually you pick the two county overlay them again. So okay, so and then look at the Google mobility. Wow, this replace all really worked. So okay, we have the Montgomery, Alabama daily cases. Okay, this does look like much higher. The previous one just on a single digit, but this now well, recently this is also single digit, the 8 and 9, but the American is just 1 or 2. So okay. This is also seems to be, and this clearly looks churn a little bit. Wow, this cases clearly goes down for Montgomery County. So this is downwards clearly. Oh, I see. This is because my smoothing is a much longer range. So if I change my smoothing to a more short distance, the data actually the last few days it does goes up a little bit. But for this smoothing function, I used 0.15. That's actually short enough. But apparently, that a few days and still didn't pick up when I smooth it with the 0.15. So that's the daily cases. Peak up from January, which is it's actually probably everywhere, at least in most places in the United States. Christmas time is the gathering time. So, and it's also quite consistent that the workplace goes down. And the trend, actually, since now we are in the Macon County, we can add the residential. Let me see where the residential there. I need to. That's the daily cases. Residential is also not available. This, I don't know. Even I thought for Montgomery, because a large city, we can see the residential. Apparently, still not. Well, okay. Yeah, but that's what the Google report is. Apparently, Google report just got on the Google residential, or even for Montgomery in the Alabama. So, well, that's what the data is. If the data doesn't have it, this